All right, let's do this. Let's take this a step further here. Okay? Let's say that I have, or you have, 7.47 grams of HCl. Okay? And I want to know what, let's see, let's not say what, let's say how many moles of magnesium hydroxide be needed to fully react with that. Okay? So we're going to, I've already got a balanced equation up here. I'm just sort of taking it a step further. Okay?
So this would come after the balanced equation?
Yes, because what we're doing, look, anytime I'm going from one species to another, I have to have a balanced equation. And I have to have a molar ratio. And it's stoichiometry. Anytime I'm going from one species to another, I have to have a balanced equation. Because I need a molar ratio. And by definition, that's stoichiometry. That makes sense?
What is stoichiometry?
Stoichiometry is the math you do in chemistry that requires balanced chemical equations. That's a simple definition anyway, okay? Stoichiometry. S-T-O-I. Huh? Yeah, the spelling's in your unit handout. Come on. Stoichiometry. All right. So what's our starting amount? 7.47 grams of HCl. All right. I can't get to moles of magnesium hydroxide without a molar ratio. And the molar ratio doesn't work if I don't first know the moles of hydrochloric acid. Okay? So, using what we did earlier, how do I get from the mass to the moles? What do I have to get there?
You need the conversion.
You need the conversion. What do we call that conversion? We need an equality statement, and the value we need is called the molar mass. Okay? All right, so we got to take the mass of hydrogen, 1.00794, and the mass of chlorine, 35.453 if I'm not mistaken. Okay, and I need to add those together. Well, now this is kind of an exception here that I will allow you. There's only one of each of those, so it seems ridiculous to be multiplying by one and everything, doesn't it?
Yeah.
So this is one exception when you don't have to do the times stuff over here, okay? But that's the only exception I'm allowing. You do have to add those together. All right. So let's see. 1.00794 plus 35.453. Oop, I got too many zeros up here. I'm not sure how I managed to do that. 1.00794. 35.43, okay. All right, and I get 36.46094. I wasn't very careful about lining up my digits, but I've got two empty slots over here. Therefore, I've got to round off two numbers.
Yeah.
And so what I get then is 36.461 grams of HCl equals 1 mole of HCl. Okay? Now you have to do all that. All those things are required in this class. Okay? You're not done with this calculation here until you put the grams of HCl on it and you put equals 1 mole on there. That makes sense?
Yeah.
Until you do all that, you're not done, and you will not get full credit for it. Okay? All right, so we're ready to build we're ready to build a conversion unit from this equality statement.
Yeah.
So we want to match the units and species of our starting amount on the bottom here. And the matching part of the equality statement is right here, grams of HCl. So that's the number and units and species that we'll put down there. 36.461 grams of HCl. And the other side of the equality statement is 1 mole HCl that goes on the top. 1 mole HCl goes on the top.
So how's that going to give us the main?
Well, now that I have moles, I can get a molar ratio to get the next step.
So we have to do another one?
Oh, yeah.
Ooh, I didn't know.
How about that? All right, so we do some math. And let's see, I got 7.47 divided by 36.461. Make sure I do all that right. The light's kind of funny for me up here. I can't see what I'm doing.
I had that problem sometimes.
All right, 272.36367. I need only 3 digits because this part of the problem only has 3 digits. These are the two calculated or measured numbers. A measured number here, calculated number here. What?
I didn't get that.
Oh, I hit the wrong button. See, golly. That is sad. That is sad. Double check your work. Double check your work. Always double check your work. Thank you.
You're welcome.
Yeah, I should have noticed that. That just didn't look right. So, did you get this, Waverly?
That's why we practice.
That's right.
That's why we don't use calculators.
Well, see, I'm using this funny light up here, and it's just, I'm going to have to get some lights that do something different. I don't know. All right, so let's see. I need 3 digits, so I'll round off from here, and I get 0.205 moles of HCl. Okay? Now that I have moles of HCl, 0.205.
You didn't cancel those things at all.
Oh, I didn't cancel. Ooh, good job. Good job. That's right. All right. So, let's see. Did I say on the recording what that means? I didn't, did I? I just said to you guys a while ago. It's a little song. You know, it matches the, what is that? Snow White and the Seven Dwarfs. Whistle While You Work is the song. And we sing to remind ourselves to cancel as we go. Cancel as you go. Okay. Thank you, thank you, thank you.
Beaver 1, Beaver 1, let's all do the Beaver go.
All right. How many moles of HCl do I put on the bottom here? How many moles of HCl do I put on the bottom here? Here's our equation up here. How many moles of HCl? Those, 2. Yeah. 2 moles of HCl. How many moles of magnesium? I'm looking for magnesium hydroxide in this problem. How many moles of magnesium hydroxide? 1. Okay. Okay, and now we're ready to calculate. So I'm going to use that 0.205. 1 divided by 2. And I get 0.1025 moles of magnesium hydroxide, which I need to round off to 3 digits. So I'm going to get 0.103 moles of magnesium hydroxide. Okay? Kind of pinched it up down in the bottom, but it's there. Okay? So there's our final answer down here. All right.
Yep.
Oh, man, that's a lot of work, isn't it?
It really is.
We're not done
What
yet.
else is a lot of work?
We're not done yet. All right. So, now, you know, wouldn't it be nice to kind of condense some of this math?
Can we?
Yes, we can. Now, let me tell you something, guys. I need to make this clear because I know that later on in college chemistry or AP chemistry, you guys are going to run up against this. Because we're rounding off at each step, we're doing something called propagating an error. So really the best way to determine your significant digits when you're done to round off is to round off at the very end after all your calculations. Yeah, no. The problem is that means you've got to keep up with how are you supposed to round off with addition? How are you supposed to round off with multiplication and division? And it gets pretty complex. Yeah. So rather than doing it in a really complex way for this class at this time, I'm having you round off at the end of each mathematical operation.
Thank
okay?
you.
No, you're welcome.